Yes, good evening all. So I held up with some ninth standard class. So I just immediately joined your class now. So hi, Prashant. Who is Prashant? Prashant, are you here? Prashant. Prashant, can you hear me? Prashant, can you hear me or not?
Sir, he is not connected to the mic.
Just not connected to the mic. Okay. Niyati, hi. How are you?
Hi, sir. I'm fine.
Yes. After a long time.
Yes, sir. I finally spoke to sir yesterday and I joined this class.
What was the problem?
I didn't have the right classroom ID.
Okay. So till what we discussed in the last class? Last class. Saturday's class. And how many of you, why didn't you attempt the test actually? Anjali, Adesha, Prashant, Niyati, Dhairya, and
Sir, from next Sunday onwards, I will be able to attend, sir,
Wait,
because
can you keep
from
the
school.
text not on Topper but on WhatsApp?
sorry,
Sir, can you keep the test on WhatsApp and not Topper?
why?
Because sir, we're more used to Topper and I don't, sorry, more used to WhatsApp, right?
No,
And
no,
I
no,
don't
it is
use
not the
Topper
case.
that much,
You
so.
see, it is not the problem, beta. Where it is easy for us to choose different type of questions in a topper. That is the reason we choose topper sometimes. Understood my point? It is not that key, in every time you have to keep on WhatsApp only. There is a easy option. Why do we why basically we go with the topper is there are 100 number of questions where we could choose easily to give the questions, different type of questions. That is the reason why we go for the topper. You can't say like that, but I don't know how to use the topper. You have to ask someone and get clarified
Okay,
how to
sir.
use that. You have to attempt. You can't say that. Why? Because in WhatsApp, if I give beta, if I can choose only 25 questions, which are somewhat high. It topper, I can find 100 number of questions. I can find 100 number of questions. I can choose very good questions and give it to you. That is the reason. Okay, it is very helpful for you only. Okay, so make sure that you all guys are you guys are attending the test without fail. How many of you didn't attempt yesterday's test? No one has attempted. Am I correct? Niyati, you didn't attempt. Prashant, you didn't attempt. Dhairya, what about you? Dhairya, what about you? Dhairya, it would be very good if you respond in the class.
Sir, not.
No. What about Prashant? No, sir. Who is Prashant?
Sir, I have joined yesterday only, sir.
Very good, Prashant. Can you please introduce yourself better?
Sir, I am Prashant of Sri Gayatri Junior College, Chanakya.
Chandanagar Sri Gayatri. Great. So you are in 12th now or 11th?
Sir.
Sorry?
12th, sir.
12th. So you did with you done with your 11th standard. You are CBSE?
No, sir.
Oh, IP. Oh, Gayatri, right? Okay. Okay. So beta, we are going with the matrices lesson. So I think we have discussed the basics of matrices. One second, let me open the notes and show it to you till what we have discussed and what we are going through, so that you also can have an idea. Look at this. We were discussing with the types of matrices, and after that operations of matrices and properties we learned, and after that we have seen how to multiply two matrices. We have seen 2 by matrix multiplication of, 2 by 2 matrix multiplication, 3 by 3 matrix multiplication we have seen. After that, transpose of matrix and properties, types of square matrices we are about to start. Am I correct? Yes or no? And
So
send
could
us.
we go through the previous ones again once?
I didn't get you. Didn't you go through the recording lecture?
No, sir, I didn't really understand that much,
Which one?
like how to add and not like. Could you just do a recap of the previous,
Yes,
what all we did?
I'll do that. But no, without fail, you have to attend the classes, ma. Without fail, you definitely have to attend the classes.
Yes,
Okay,
sir.
I'll give us a quick recap what we have done so far. But basically, what we learned from the matrices is, look at this, matrices. Matrices. Matrix is nothing but what? Matrices is a plural form of the matrix. What do you mean by matrix basically? Matrix is nothing but representing a real or imaginary number in a rectangular array. Like this. Okay. Basically, I'll be denoting the order of the matrix with m by n. I'm sure Prashant and Dhairya, your IP is board, IP student only, right? Intermediate public examination, Telangana board.
So CBSE.
CBSE, no problem. Yes, very good, Dhairya. I'm happy you are responding in the class. Thank you. Neti, CBSE, Prashant, okay. No problem. Prashant, I think you might have done in class 11th itself. Am I correct, beta?
Yes, sir.
You know Telugu, right?
Yes, sir.
Fantastic. So you have already done in class 11th. So here for CBSE beta, it will be in class 12th, matrices lesson. For IP, intermediate public examination, but it will be in 11th only, matrices lesson. So no problem. What is it, Prashant? It does not mean that we will be going with everything from the scratch. I'm very soon in this class, I'm going to start with the JEE questions. Okay. Already have done introduction, but your friends are requesting me to recap once again. So that is the reason I'm just going through beta. Okay. Clear?
Yes, sir.
Yes.
Yes, sir.
And please 7:30 have a demo. Please do remind me. Today's class would be, I'll be leaving it at 7:28, something like that. So why?
Okay,
Because
sir.
whatever the loss of time we have, definitely I'll be compensating the next class. Okay, there is no doubt at all. So you remind me.
Okay,
Okay.
sir.
There is whatever the loss of time we have, 2 minutes or 10 minutes, whatever we have, 15 minutes, I'll take 20 minutes extra. No problem. If you want me to take 15 minutes, I'll take 20 minutes extra. But you have to remind me. That is your responsibility. Let's see how many of you are going to remind me. If I'm leaving on time, you have to remind me, sir, can you please take 10 more extra minutes? Definitely. 15 minutes extra. Definitely. Why not? But remind
Okay,
me in the next class. Today, I have a demo I have to attend, must and should. That is very important to class. Okay. Chalo. So matrix is nothing but what beta? Arranging elements in a rectangular array. So this is how you represent matrix in a box, rectangular box. What is this? M by n is nothing but m is number of rows. N denotes number of columns. Okay. And beta, look at it. First, suppose if I write a matrix 1, 2, 3, 4, 5, 6. How many rows I have beta here? R1 and R2. How many rows I have? How many columns I have? 2 rows and 3 columns. Very good, Prashant. So 2 rows, 3 columns. So this is how I write here. M cross n. M is row, n is column. So 2 by 3. Very good. Hope it is clear, Adyasha. Anjali. Anjali, clear
yes,
or
sir.
not? Niyati, is it clear, Niyati?
Yes, sir.
I think this is the first time you're hearing about the matrices. Am I correct?
No, sir, I was there last year when you
Yes, yes.
explained in the.
Very good, very good. So now look at it after this beta. This is the order of the matrix. Order of the matrix is what? Number of rows by number of columns. Now types. In types, what we learned beta? Row matrix. Row matrix. What is row matrix? Having only one row. Having only one row. Like 1, 2, 3. How many rows I have, Anjali, here?
1 row, sir.
Only one row. Column matrix is what? How many columns? Column matrix is nothing but having only one column. That's it. Row matrix, column matrix is nothing but what? Having only one column like this. 1, 2, 3. How many columns I have here? Only one column. Only one column. Okay. Next. After this, what we learned? Square matrix. Square matrix is nothing but what? The number of rows and number of columns are equal. So m is equal to n basically. Correct? M is equal to n basically. So if I say A, B, C, D, how many rows I have here? How many rows? How many rows beta? 2 rows and 2 columns. 2 by 2
2
matrix.
rows and 2
Here
columns.
m and n both are equal or not? So wherever you have m and n are equal, they are square matrices. Now diagonal elements, diagonal elements, diagonal elements. If I say beta, look at this here, A, B, C, D. Here, these are my diagonal elements. Correct? A and D are what? Diagonal elements. Now, if I say diagonal matrix, what is diagonal matrix? Diagonal matrix is nothing but, look at this, I'll tell you. For suppose, look at this, everyone must be 0 for 1, 2, 3, and all these people should be 0 here. Okay, there should be elements in only diagonal position. This is a diagonal position, and remaining everyone must be 0. That is diagonal matrix. Diagonal elements is different than diagonal matrix. Diagonal elements is nothing but only these elements. Correct? In diagonal matrix, everyone must be 0 except the diagonal people. Okay, clear? Is it clear?
Yes, sir.
Now scalar matrix. What is scalar matrix? Scalar matrix is nothing but beta. Look at this here. Scalar matrix is nothing but in diagonal position again. There should be any number. There should be any number, but the same number. Look at this here. Let me write here 2 I'm having. So 0, 2, 0, 0, 0, 2. This is my scalar matrix. There should be elements in only diagonal position, but a same number everywhere. Correct? And remaining all people should be 0. Correct? Prashant, any doubt? Prashant? Darya, any doubt? Darya, please do respond. It is very
No, sir.
important. Responding to the teacher is very important in the class. It is for your life. If you do not understand anything, you can straightforwardly say that, yes, sir, I'm not understanding. But when I'm calling you, if you don't respond, it irritates the faculty. Please kindly understand, everyone should respond. It is a very we are having a jolly, like, what do you call that, joyful class. I'll not be taking the classes very seriously. I'll be taking the classes in a funniest mode. Yes, that is what my teaching style would be basically. Okay, so make sure that you guys are responding to the questions which I'm asking to you. Scalar matrix is nothing but beta. In a diagonal position, everyone must be same, but same number, and other people should be 0 everywhere. Wherever you see, everyone should be 0. Correct? So next, what is identity matrix? Identity matrix is nothing but what? Identity or unit. Unit matrix or identity matrix, anything is correct. Both are same name. Okay, so unit matrix is nothing but beta. All the diagonal elements must be 1. Correct? Diagonal elements must be 1. Other than 1, there should not be any other element. So diagonal elements shouldn't be equal to 0. Correct? Understood, beta? If diagonal elements 0, what happens, beta? Guy, I'm going fast. I know that I'm going fast. Why? Because it is a revision. It is a recapping. I'm not teaching from the scratch. Already we have taught all this, but for your request, for your concern and the basis of, sorry,
the identity matrix only has to be 1, or it could be any number that's not
only
0?
1. Identity unit.
Okay.
Unit is nothing but 1, right? Unity,
Yes, sir,
one
got it.
group. Yes. So it should be 1 in the diagonal position. Okay. Yes. Now coming to beta, zero matrix or null matrix. Can you please tell me what is null matrix? All the people should be 0. This is null matrix. Understood my point? Understood
Yes,
my point? Now, sir, all this now, diagonal matrix, scalar matrix, identity matrix, null matrix, all these people should be what? Square matrices. All these people should be what? Square matrices. Look at this 3 by 3 order here, 3 by 3 order here, here also 3 by 3 order. Correct?
Yes, sir.
Here also 3 by 3 order. Okay. Now can you say beta, can identity matrix can be a scalar matrix? Yes, it is. Scalar matrix is nothing but what? Diagonal people should be same. It could be any other number other than 0. It could be anything. Correct? Prashant, are you able to understand?
Yes, sir.
What is identity? Can identity matrix can be a scalar matrix?
Yes, sir.
Why?
Sir, same diagonal numbers, no, sir.
Same diagonal elements. It should be same number.
Are same.
Yes, it could be any number. It could be any number other than 0. 0 shouldn't be there, but other than 0, it could be any number. That is a scalar matrix. But for unit or identity matrix, especially, it should be 1 only in the diagonal position. Correct? Yes.
Yes, sir.
Perfect. Good. Fantastic job. Now, next we'll go for triangular matrix. What will end better? Triangular matrix. Triangular matrix. Triangular matrix is nothing but beta. Look at this here. So if I have 1, 0, 0, 0, 2, 0, 0, 0, 3. Triangular matrix is nothing but beta. See, what is my diagonal position now? Diagonal elements are what? 1, 2, 3. Here, diagonal elements is what? 1 to 3 or not? Either above or below the diagonal position. If you have zeros, that is a triangular matrix. What is that? Either above or below. If at all have zeros, that is a triangular matrix. In triangular matrix, we have two types: upper triangular and lower triangular. Correct? Upper triangular and lower triangular. Yes, I shared all the notes in Google Classroom. You can open that and just have a look at that. Upper triangular and lower triangular. Upper triangular is nothing but what beta? Having downside 0. Lower triangle is nothing but what beta? Upside 0. Correct? Let me tell you, Babu. 1, 2, 3, 0, 4, 5, 0, 0, 6. Now tell me whether it's upper triangular or lower triangular. This is upper triangular. Why? Because this is my diagonal position where 0 I am having here, downside part. So down means upper. If I have zeros downside of the diagonal elements, that is upper. అరే భాయ్ తెలుగులో చెప్పాలంటే సింపుల్ గా జీరోస్ కింద ఉంటే అది అప్పర్, పైన జీరోస్ ఉంటే అది లోవర్. వెరీ సింపుల్, ఆపోజిట్. Getting my point? Understood my point, guys? If at all my zeros are downside of the diagonal elements, that is upper triangular. If my zeros are above the diagonal elements, then what is that?
Lower triangular.
Very simple. Look at the same example you take here. 0, 0, 0. Now here 3, 4, 4. 1 second. 1 second, guys.
Sir.
Yes, guys, I held up with something. Okay, no problem. Look at this here. Here 6. Now look at it. This is my diagonal, beta. This is my diagonal. This is my diagonal. Now look at this here. Above of the diagonal is what? Zeros here. So this is what? Lower triangle. Understood now? Understood? Any doubts?
No, sir.
Fantastic. Now after this, beta, what we learned? Equality of matrices. Equality of matrices and next. Oh, 1 second. Equal matrices. Equality of matrices. Equality of matrices is nothing but beta. First, suppose I have A, B, C, D. This is my A matrix. Okay. 1 second. 1 second, guys. Yes. Look at this, guys. If A is equal to this one, and for suppose this matrix is equal to 1, 2, 3, 4. Equal matrices is nothing. But if I ask you to find out A, B, C, D values, A is equal to 1 beta, B is equal to 2 beta, C is equal to 3, D is equal to 4. I'll be equating corresponding elements. A is equal to 1, B is equal to 2, C is equal to 3, D is equal to what? 4. That is equal matrices. Correct? Equality of matrices is nothing but what? I'll be equating corresponding elements. So when can you say two matrices are equal? If their orders are same. Look at this. Order of these two matrices are equal matrices or not? Beta, order of these two matrices are equal or not? This matrix also 2 by 2, this matrix also 2 by 2. I'm writing roughly, I know that, but I already shared all these. Please go through that, okay? But if I say equivalent matrix, equivalent matrix is nothing but beta. Look at this here. First, suppose I have two matrices. For equal matrices, for equality of matrices, what was the condition? Number of what? I mean, order should be same. Order of the two matrices should be same. Here, order must be same, beta. Order same. And here, order must be same as well as corresponding elements. What are they? corresponding. Here order must be same and we will be equating corresponding elements in where, in what, in equality of matrices. But in equivalent matrices, equivalent is nothing but what, beta? Order must be same, but we will not be comparing corresponding elements. Okay, we will not be, no comparison, not comparing corresponding elements. I am writing, beta, look at this roughly. I already taught you all this. Please go through the notes. Clear? Any doubts here? Equality is nothing but order
No,
must be
no,
same.
sir.
Corresponding elements will be equating. Equivalent is nothing but what? Order must be same, but we will not be comparing corresponding. Very simple. Chalo, next. Now operation, beta, algebra of matrices. Algebra of matrices. Algebra of matrices. Algebra of matrices is nothing but beta, addition, subtraction, multiplication. There will not be division in the matrices. There will be no division in the matrices. There will be no division in the matrices. Yes, Mohammad Jafar. Who is Mohammad Jafar? Mohammad Jafar Sadiq. Mohammad Jafar Sadiq. Salam alaikum ji. How are you? Mohammad, can you hear me? Hello. He has not connected the mic. Mohammad ji, are you here? Hello. Can you respond? I think he is not in a position to respond. Okay, leave it. Algebra of matrices is nothing but beta sum. If I have a matrix, if adding that matrix, the result is going to be what? If I have 2 by 2 order matrix, this is also 2 by 2 orders matrix. The resultant matrix is also going to be order of 2 by 2 only. Correct? That is addition. Same thing with negative minus as well. Same thing with the subtraction as well. How to add two matrices? Let's say 1, 2, 3, 4 plus 5, 6, 7, 8. What is the order of this? What is the, how to add these two matrices? 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, 12. Correct? Any doubts? Any doubts? Till this, any doubts, people?
No, sir.
Anjali, any doubts? I'm adding corresponding elements. Subtraction also same thing. Now what is A minus B now? Let's say this is A, this is B. How to add AB? Subtraction is nothing but what? In place of, instead of plus, I'll be doing minus. That's it. That is subtraction. But this is a fourth standard. Yes. Sorry. So what is A minus B now? Tell me. Minus 4, minus 4, minus 4, minus 4. That is what? What is that? A minus B. Correct. Now matrix multiplication. Matrix multiplication. Matrix multiplication. Here you have two types of multiplications. Scalar multiplication. Scalar multiplication. One matrix into matrix. I mean multiplying a matrix with another matrix. Okay. So scalar multiplication is nothing but beta. If I'm having a matrix, let's say 2, 3, 4, 5. I'm taking any scalar called k. If I multiply, I can multiply that k gets multiplied with each and every element. That is a scalar multiplication. 2k, 3k, 4k, 5k. What happens here? That k gets multiplied with each and every element of that particular matrix. That is scalar multiplication. Now, multiplication, matrix into matrix. How do you multiply? If I have a matrix, beta, let's say 1, 2, 3, 4, 3, 0, 1, 2. How do you multiply this? How do you multiply this? Every row gets multiplied with every column. And this row multiply with this column, this row gets multiplied with this column. How? Look at this. 1 into 3 plus 2 into 1. 1 into 0 plus 2 into 2. 3 into 3 plus 4 into 1. 3 into 0 plus 4 into 2. Understood, Anjali? Guys, I am sure you all. Yes, I'll repeat again. I'll repeat. Better what I'm doing here is first element into first element. First element into first element. Now, first look at this. Observe what this is my row 1. Row 1 gets multiplied with column 1 as well as column 2. So in the row 1, what is the first element? 1. Here first, that will multiply with first element. Again, second element goes with the second element. So that's what I got here. Correct? Again, okay. This 1 go with 0. Look at this. And 2 go with 1. Why? Because corresponding, right? Second element. Now R2. Coming to R2. Now this R2, beta, look at this here. This R2, the first element goes with this one. Second element goes with this guy. Again, 3 goes with 0, 4 goes with 2. So if I solve all this, what do you get? 1 into 3, 3, 3 plus 2, 5. 5. So 0, 4, 9 plus 4, 13, 8. This is my matrix multiplication. Mohammad ji, are you here, Mohammad ji? He has left. Guys, I was revising. I'm revising again. Is does not mean that you guys are not, those who are absent, they are not watching the recording video. If you watch, there will not be any problem. There will not be any kind of problem. Look at it. If I have 3 by 3 matrix, beta 1, 2, 3, 4, 0, minus 1, or you say not minus 2, 1, 1, 3. You take 1, 2, 1, 1, 2, 0, 0, 1, 2, 1. Look at it. How do you multiply this? How do you multiply this? Anjali, can you please tell me the row 1 of the resultant matrix? I told you very important thing. I forgot, beta. I forgot very important thing. Before matrix multiplication, beta, look at this. You have to check the orders. Beta, look at this here. For suppose here A cross B and C cross B. Okay. Or you say B cross D, B cross C. For matrix multiplication, beta, Anjali, this B should be equal to B. Okay. What is B here? Number of columns. What is this B here? Number of rows in the second matrix. Correct? This A matrix, this is a B matrix. What is this small b denotes
Yes, sir.
here? Number of columns in a first matrix. What is this B denotes here? Number of rows in a second matrix. Both should be equal. Then only you can multiply two matrices. If not,
So
you cannot
both
multiply.
rows and columns have to be equal for multiplication to happen.
No. Columns of first matrix and rows of second matrix must be equal. Understood?
Sir. Okay, sir.
What is the resultant order now? What is the order of the resultant matrix? A by C. What is the order of the resultant matrix? This by this. The last element shows you resultant order. The middle element must be equal for multiplication of matrices. Correct? Now let's check here. What is the order of this matrix? 3 by 3. What is the order of this matrix? 3 by 3. Now check whether these are equal or not. Equal or not? Equal. So matrix multiplication is possible. If it is possible, what is the order of the matrix after multiplying? 3 by 3 is my order. Correct? Understood? Anjali?
Yes,
Hello?
sir. Understood.
Now how do you multiply, beta? This row gets multiplied with this column. So 1 into 1. This 1 goes with 1. So 1. This 2 goes with 1 plus 2. This 3 goes with 0 plus 0. Now again, this 1 goes with this 2. So 2. This 2 goes with this 2 plus 4. This 3 goes with this 2 plus 6. Now again, this 1 goes with 1. 1. 2 goes with 0. 3 goes with 1. Like that you solve this and find out the answer. Understood my point, Anjali? This is how the order of the
Yes,
three.
sir.
This is how the order of the resultant matrix. This is what we discussed, beta. This is what we discussed. And after the transpose of a matrix, we came to know. We discussed after the transpose of a matrix. Transpose of matrix. Transpose of a matrix is nothing but beta. Look at this here. For suppose I have A, B, C, D, or else you write elements in numbers 1, 2, 3, 4. Let's say this is A matrix. And Anjali, look at this here. Sir, why you are writing only capital letters here? Matrix name should be always capital letters. And inside the element could be, inside the element, there could be what? Small numbers. Okay. But matrix name should be always capital letters. Now, transpose we denote with like this. A transpose is nothing but transpose of A matrix. Here what happens is the people who are sleeping, they'll wake up. Basically, sleep is equal to wake up here. Sleep is equal to wake up. Sir, what sleeping? What wake up? What you're talking about? Arey baapre, look at this here. Here, rows becomes as columns, beta. Okay, rows becomes columns, columns becomes rows. That is what equal to sleep is equal to wake up. Understood? These people are sleeping here. These guys will stand. These people are sleeping here. These guys will stand. That is a transpose. How the Josh? How is the Josh, Prashant? Prashant, how is the Josh? How is the Josh, beta?
Nice, sir.
Hi. How is the Josh, Dhairya?
Hi, sir.
How is the Josh?
Hi, sir.
Very good. Which movie dialogue is this, beta? Tell me.
Puri.
From
Uri.
Akshay Kumar movie.
देखो देखो, डायलॉग पूछने से जल्दी आंसर मिल रहा है मुझे, मगर क्वेश्चन का आंसर जल्दी से नहीं मिलेगा। हाँ धैर्या जी, हाँ, या आई एम जस्ट जोकिंग, या फाइन। हाउ इज द जोश? हाई, always it must be high. Okay, yes, but I know, I'm telling again and again, I'm going very fast just because of I already finished all this. I do not want to waste much time on the concept which I already discussed. For that, you go through the recording, watch it. If you don't understand, then you come to me and ask. Without watching the recordings, please do not ask. Go and revise the notes, everything. Don't need not to write what I'm telling you now. Go and look at the Google Classroom. You can download the notes, everything neatly provided to you there. Whatever I write in the class, everything I'll be uploading after the class. Okay beta? Yes. Now Varsha, I forgot Varsha. Varsha, who's Varsha? Varsha, hi Varsha.
Good evening, sir.
Hi, how are you?
Fine, sir.
Yes, where are you from basically? Can you please introduce yourself?
Sir, I'm from Hyderabad.
You're from Hyderabad. Which place in Hyderabad?
Kondapur.
Kondapur. You're from Kondapur. Great. So basically, where you are studying, Hasha? Vasha?
Sir, Hyderabad.
I know that you are studying in Hyderabad only, but which college I'm asking?
Meridian.
uh,
Meridian, sir.
Meridian. Great, great. You are in 11th or 12th? I mean, are you promoted to, are you a student of promoted 12th batch?
Yes, sir.
Okay, okay. 11th to 12th you promoted. CBSE or board? I mean, state board.
CBSE.
Great, great, great. So this is this might be the first time you are learning about matrices. This is the first time, right?
Yes, sir.
So have they started with the matrices lesson from your school side?
No, sir. First chapter, sir,
First chapter?
has been started.
Okay, they have started with the first topic. So see here, I was discussing matrices beta. That is your third topic of class 12th. Matrices is a third topic in class 12th CBSE syllabus. Okay, so I started that. I was revising you. This is the second time I'm teaching this for the students. So I think you are a new student of this institute. You do one thing. We have a our recordings uploaded channel, so you can just go there beta and watch all the recording videos. I think I didn't take many classes. There is a two recordings, I think. You can go and watch that. You can have you will get, I'm sure you will get a proper idea. You'll get a command on basics of the matrices, how to add two matrices, how to multiply two matrices, how to add two matrices, subtract two matrices, how to multiply with a scalar, what are the properties of the uh, uh, algebra of the matrices, what are the properties of the transpose of a matrices. Everything has been it's been discussed in a clear cut manner. So you can go through that and ask me the doubt, come up with the doubts, come up with interesting questions. That is a very great quality as a JEE aspirant you must have. You understand what I'm talking, Varsha?
Yes, sir.
Yes. Are you sure? Are you understanding?
Yes, sir.
If you don't understand anything better, you can ask me. Yes, I'm sure that you are first time, you are you joined a bit late as well. Please be on time for the next class. Okay. So that you can follow the track. If you miss the flow, what happens is you will lose everything. For the next class, if you miss this class, you will not understand the next class. If you miss that, it is a kind of cyclic process. If you don't understand one thing, that affects another class. So make sure that you all are joining on time and making it as a huge success. Make a utilize of the time which you have, please. Okay. Prashant, are you able to understand what I'm talking?
Yes,
Prashant
sir.
ji, are you sure?
Yes, sir.
Great. Where are you from, Prashant?
I am
Chanakya.
from Patancheru, sir.
You are from
Patancheru.
Patancheru. Okay, okay, fine. Look at this. So now we'll talk about properties beta. Properties of transpose of matrix. Okay, I'm revising you. Look at this here. Beta was first property is what? If I said A transpose, old transpose. A transpose of old transpose is equal to A only. Okay, I detailedly explained you in the recording videos. Go and watch through that. Okay, now if I multiply any scalar matrix with A matrix, and transpose of that can be written as K into A transpose. Okay, K into A transpose. What is K here? What is K here? Varsha, what is K here? K is a scalar. Correct, Varsha? Are you here or not?
Yes, sir.
Yes. K is a scalar, beta. Scalar is nothing but any constant. That is what I meant to say. Fourth property is beta A, B, all transpose is equal to B transpose into A transpose. Ulta. Here reverse law. Okay, here reverse law. Ulta. It is not like many students will write like this. This is wrong. A transpose into B transpose is wrong. B transpose into A transpose is correct. Correct? Till this we discussed, and after this what we learned is types of square matrices. Types of square matrices. I'm requesting again and again those who were absent, kindly go and watch the recordings. You have only 2 recording videos. If you postpone that as well, what happens? You'll be having dump of videos. You cannot even watch fully at a time. So I'm telling you, beta, you have only 2 videos. Finish it up by tomorrow. You will be having a class again day after tomorrow. So by day after tomorrow, you have to finish that, go through the notes which I have provided, and revise that, and come to me if you have any doubts. So is it clear, Varsha, Anjali, Dhairya, Prashant, and Niyati? I'm not getting an acknowledgement from any one of you. Is it clear?
Yes, sir.
Is it clear, Varsha, Prashant?
Yes, sir.
Great. First matrix is symmetric matrix. Symmetric matrix enna beta? What do you mean by this? A transpose equal to A. Now skew symmetric matrix. Types of matrices. This is the first time I'm teaching you. Now look at this here. A transpose is equal to A beta. I'll give an example. Everyone, those who have already been here, you have to start writing from this point. So far, whatever we have discussed beta, that was a revision. This is a fresh concept. Types of square matrices. The first type is symmetric. Symmetric matrix is nothing but what? A transpose is equal to A. What is the meaning of that? If I say beta, A is equal to 1, 2, 3, 4, 5, 6. A transpose is equal to what, Varsha? Can you please tell me? Varsha, can you tell me what is A transpose here? Varsha ji, are you here?
Yes, sir.
Yes. Rows become columns. That's it. This is a row, right? This is a row 1. This is row 2. That row become column. That's it. And the column become row. That's it. Understood my point?
Yes, sir.
Row become column. Column becomes row. That is a transpose. What is the order of this matrix, beta? 2 rows and 3 columns. And what is the order of this matrix? A transpose matrix? 3 rows, 2 columns. So basically in transpose, what happens? If at all you have a matrix of order m by n, that becomes n by n order. Correct? That becomes n by m order. That is a transpose. Now look at this beta here. If at all that is A transpose, that is A transpose, and that is a transpose of matrix. But here, if at all, even a transpose beta, even a transpose, you have to get still again A only. You take any example, Babu. Here, for the example, any matrix, you tell me which, even a transpose, that you must get the same matrix. Let's see how many of you tell that. Tell me. Hello? Any example? But a very simple beta. Look at this here. For suppose if I say A example, A matrix as 0, 5, minus 5, 0. Okay, 0, 5, minus 0. Now what is transpose? Now this example will not work out. I'll give one more example. You say like this: 9, 2, 3, 2, minus 1, minus 8, 3 minus 8, 0. What is transpose of this? Varsha, tell me now. What's the transpose? You have to see, everyone should respond here. If you're showing your enthusiasm in the class, what happens here is beta, it will be a great impact. It creates such a lot of interest to what's listening the class. If you do not listen, what happens? You will not get the concept. Yes, I'm sure you all are listening, but if you do not respond, if you do not show that enthusiasm, you will not understand. So tell me what is the A transpose here. Tell me, Varsha.
So first row 9, 2, 3.
First row 9, 2, 3. Fantastic. This row becomes column. That's it. I mean, this row becomes the column. Now look at 9, 2, 3. Let me write. Second row 2 minus 1 minus 8. 3 minus 8. 3 minus 8, 0. Now look at it. Still it is looking like A matrix or not? Even a transpose beta, it is looking like A only. That is symmetric. Correct? Understood?
Yes, sir.
Now see, skew symmetric matrix is nothing but what? Skew symmetric matrix. Skew symmetric. Next type of matrix is skew symmetric. Skew symmetric matrix. First one is symmetric. Second one is skew symmetric. Skew symmetric is nothing but A transpose is equal to minus A. What is the condition for this? A transpose is equal to minus A. And now let's see an example. For suppose A matrix, you have like 0, minus 1, 2. Okay. Do you say any example, Babu? 0, 3, minus 2, minus 3, 0, 4, 2, minus 4, 0. Correct? What is A transpose? What is A transpose now? What is A transpose? Tell me. 0, minus 3, 2, 3, 0, minus 4, minus 2, 4, 0. The columns become rows. That's it. Now look at this. Taking minus common. If I take minus common, what happens from every element? 0, 3, minus 2, minus 3 here, 0, 4, 2, minus 4, 0. I took minus common. Isn't it better? I took minus common. From this matrix, I took minus common. So now, is it the minus as it is I'm writing here? Is the matrix is same as like as A matrix or not? Check. Check. Is it correct or not? So this is my A transpose. So A transpose equal minus A. This is what the skew symmetric matrix. Is it clear? Is it clear with everyone?
Yes, sir, it's clear.
So A transpose is equal to minus A is skew symmetric matrix. After this, you have few more concepts beta. I'll be continuing the next class. I have very emergency and urgent class. I have to take it out now. 7:30 only have. I have just left with only 2 minutes. So make sure that you all are revising the notes and come. Please. It is my
Okay,
humble
sir.
and kind
Yes,
request.
sir.
If you are not revising beta, I'm sure you will not at all understand anything. That is for sure. I can write on the bound paper and give. I can give a surety 100%. Revise. If you are listening the class properly, it takes hardly 10 minutes to revise the notes, not more than that. And those who are absent, you go through the recording videos and go
Yes,
through the
sir.
notes which has been uploaded in the Google Classroom. Okay, Varsha, Prashant,
Okay, sir.
Dhairya, ठीक है जी?
Yes, sir.
Okay, Dhairya. Chalo, let's make a move now. We'll meet in the next session. Goodbye. Thank you.
Thank you, sir.